Yes, hello, good evening. Yes, my name is Thomas Vögele. I'm with the Robotics Innovation Center in Bremen, run by the DFKI, the German Research Center for Artificial Intelligence. And to pick up right on that question that came up in the last panel, no, so as far as I know, we are not yet working together with Polytechnic Montreal, but I was following the presentation with very much interest, and I learned that now Canada is in a rise in Europe, so maybe in the future there will be opportunities, and we definitely should be in touch.
We will make sure Matthias Vögele will bring business cards for you from Montreal, okay?
Great. Okay, so after we heard AI, the role of AI in in orbital applications and spacecraft, I want to give you some high-level ideas about about the role of AI in planetary exploration, and also mostly the challenges and the limitations we face there. And I apologize to the AI geeks among you. Maybe this is boring for you, but I think it's important to think about what AI really can do and where its limitations are. First, one slide on where I come from. The DFKI is a non-profit research and technology organization. It was founded 35 years ago in the southern part of Germany, Saarbrücken and Kaiserslautern, and it spread out to the rest of Germany now. And we are in 6 locations in Germany. We're about 1,200 researchers specialized on artificial intelligence research. And in Bremen, we have a group of about 100, 120 researchers working on AI and robotics. So what we do is we kind of incorporate, or we try to incorporate AI into robotics. And one of our main areas of research is actually space exploration and planetary exploration. And I mean, it's obvious planetary exploration is something where you need robots for. This is really a key application field for any roboticist. It's not only cool, it's also really necessary to develop robots that are clever and autonomous in the future, that can explore Mars, Moon, but also planets that are further away. At the moment, what we see so far is robots that are more or less remote controlled, like Perseverance, the NASA rover on the Mars. It is maybe one of the most sophisticated rovers at the moment, which is in action, and it has some capabilities of autonomy. For example, it has an autopilot called AutoNav, which allows it to move 200 meters per day. So this auto navigation, it can calculate the trajectory and avoid obstacles and replan the trajectory, and it can move 200 meters per day, which is a lot compared to other previous missions. But of course, if you look at the size of Mars, it's not very fast, really. And there should be some improvement to this in the future. But why is it so slow? It's slow because actually this very sophisticated rover has a brain which is comparable to a 1997 PC, or it has actually 2 CPUs, but these are not very powerful. So it needs a lot of time to process data and to recalculate the path. And this is due to the fact that we cannot use high-end hardware for computing on planetary surfaces due to the radiation. So space-qualified hardware is still very slow. In DFKI, we are able, of course, we do systems which are tested on Earth and kind of proof of concept demonstrators. So we can use terrestrial technology if you want. And so we managed, for example, within 8 hours to cover 1.4 kilometers here in Morocco with one of our rovers called Sherpa. And this is already quite good, but I would say it's not really using AI. It's using kind of classical approaches, classical control methods for obstacle detection and creating traversability maps and do pathway planning. So it's a progress, but it's not really AI. Another example is are these two robots that were used to explore a lava tube, a lava cave on Lanzarote. It was a field test done this year, early this year. And these two robots cooperate, and the whole sequence of actions is actually autonomous. But still, we're using classical method, if you want. We're not using any data-driven, any AI, any machine learning. So this brings me to the question, well, what actually is AI? Maybe we have to think about, I mean, AI today is very much used as a, in terms of data-driven AI. But when I started my PhD in 2000, the so-called symbolic AI was still very much in fashion. And what we tried to do there, we tried to kind of squeeze the brain of an expert, like a geologist, for example, and bring it into a formalized ontology, kind of a data structure, which is computer readable, and you can run some logical programs on it. And the thing was that even a simple task, seemingly simple task like classifying rocks, was not really possible with such a simplified approach, because what is missing is the whole context knowledge that the geologist has. And this could not be easily formalized. So everybody was a bit frustrated about this approach, and everybody was really happy when the data-driven AI came up. So neural networks, which had existed before, they were kind of revived because all of a sudden we had thousands, millions of pictures and other data on the internet. And this spawned this whole AI hype, which is currently going on. And which means that most people who talk about AI are thinking of this type of AI, actually. And just as a brief reminder to you, what does this AI do? Actually, it's a very simple, here in a simplified version, you feed a lot of pictures, like for example these cat pictures, into a neural network, and you tell it, okay, this is a cat. Then when the neural network is trained, it can actually detect, it can say, okay, you feed it another picture, and it can say, okay, yeah, this is a cat. Great. But what happens when you feed it, for example, a picture of a lion or so? It would not say, okay, this is also a cat, but a different one, because it doesn't have any context knowledge about that a lion is a cat animal also. And if you feed something like a horse, then it would just, the only thing it can say is, okay, I don't know what this is. It's definitely not a cat. So the problem is, the network can only identify what it is trained for. And when we're looking at planetary exploration, you know, we're probably going to find things that we are not, we cannot train our systems for, because we don't have the data to do that, and we don't know what's out there. So to summarize the challenges we're facing, first challenge is the lack of high-speed, high-performance, space-qualified hardware. And I'm sure that this is maybe the least problem. I think it can be resolved, and it's a technical problem, so there will be a solution for it. The question is how long it will take. The second, much larger challenge, in my view, is the lack of training data. And this is really hard to do, because simulations or analog missions, I don't think that they are able to provide the training data you actually need. And AI systems have proven to be very sensitive to actually the training data they use. So this is a problem, which I don't have a solution for. So, and the last challenge is related to the first one. To the second one is, what happens if we meet something that's truly unknown and unexpected? I mean, it's maybe a philosophical question. Humans might also not be able to detect something like this. Maybe you know the Solaris novel by Stanislav Lem, where the whole ocean is actually a living being, and the people don't detect that really because they're not used to it. So, but what could happen is, and let me finish with this nice funny picture, video at the end. We could have a robot that is really kind of smart. It can kind of take samples. It has some kind of it has some built-in spectroscopy or something like this to analyze. But then it goes to, when it finds something new, it thinks it's a rock. Thank you. But then something unexpected happens, and this rock is actually an egg of a small alien, right? But now, what does the robot do? I mean, it's great. He has discovered an alien, but it's not trained for this. So what it does, it kind of does the normal procedure, you know, and that was it with the alien. So this, by the way, this video was made by HFF in Munich, and I saw it on in 2015 on a future contest for future videos. So with this, I want to close, and yeah. So the problem really with data-driven AI is we need more data. That's the big issue. Thank you.
Thank you, Thomas. Thank you.